Einen wunderschönen guten
A
Morgen.
wonderful good morning and a warm welcome to ISH Digital 2021. My name is Lisa Pavicic, and on behalf of World Architects, I would like to welcome you for the last session of our series of lectures that we are holding in cooperation with Messe Frankfurt. You can find our presentations in the media library just in case you miss out on a single lecture. World Architects has successfully offered guided tours for many years at ISH at Messe Frankfurt, and this year we had to virtualize our tours, so we have put a selection of stands and providers and manufacturers that we would have liked to visit online. You will get credit points for further training for attending this event. Feel free to use the email address that is provided at the end of the lecture to claim your credit points. During the lecture, we are inviting you to note down your questions in the chat, and they will be discussed with Markus Pfeil. Markus Pfeil studied mechanical engineering, specializing in energy systems and environmental engineering. For more than 25 years, he has been dealing with innovative energy concepts for buildings. Together with Holger Koch, he founded the Pfeil & Koch Engineering Company, based in Cologne and Stuttgart, and they develop innovative energy concepts with a focus on a holistic concept utilizing renewables such as solar energy, geothermal energy, and biomass. He is a lecturer and a professor at the Münster School of Architecture. In today's presentation, he is going to show how his office plan, design, and implement holistic energy concepts. Good morning, Markus. Good morning, Lisa, and thank you very much for your introduction. It's my pleasure to speak about energy concepts today, high-tech and low-tech solutions, and a picture that may be graphically beautiful but shows a disaster is this one. This is the climate crisis. Ever since temperatures have been recorded, the most outstanding extremes were observed in the past 20 years, represented by the red lines on the right. So we are in the midst of a climate crisis, and we have a target that we need to attain, a maximum of 1.5 degrees of temperature increase vis-à-vis the pre-industrial era in order to prevent even worse disasters to happen to our world and future generations. It is doable, but it is an ambitious goal. By 2050, we have to become carbon neutral. This is the EU target. It is attainable, but it requires a lot of effort, and the building sector plays a key role here. What are the transformations we need to achieve to get there? There are three pillars of transformation, of how to get there in the EU and in Germany to become climate neutral by 2050. There is a publication on climate neutral Germany. You can download it from the website of the Wuppertal Institute. We have to increase our efficiency levels in order to lower demands. We have to opt for renovations, more efficient power plants, district heating, green district heating. These are all issues that we can tackle in the short term. The second pillar is renewables. Fossil energies will have to be phased out. The carbon emissions must definitely be reduced, and those that are hidden in the soil below our feet should stay where they are. So renewables and electrification are a promising combination. Electricity is very flexible, and of course we have to make it storable, but it enables us to work decentrally, and this enables us to make a major contribution. The third pillar, pointing even further towards the future, looking ahead a few decades, is hydrogen. Hydrogen will be the oil of the future. Think of aviation or heavy-duty transportation. For these options, we need a highly efficient fuel such as hydrogen, which has to be, however, generated by using renewable energies only. As engineers, whenever we think about the future, we think efficiency. We want to improve systems. We want to devise more highly efficient machines such as heat pumps, photovoltaics. So that's the typical engineering approach. But sometimes we tend to forget about the fact that at the same time we are part of a growth movement. What is this growth movement all about? Is it really all about efficiency? Well, you tend to focus on high-tech solutions only, but then you have a rebound effect because you become ever more demanding. We become more demanding with a view to air conditioning. Comfort indoors is something that eats up efficiency gains and leads to ever higher demands. And this is why we would like to come up with the term of sufficiency. This concept is going to become more relevant in the future. It seems like they want you to forgo something, and this may seem to make it unpopular, but sufficiency means to live with moderation. Less is more. Sometimes if you go slowly, you go more reliably, and it's about quality rather than quantity. And this translates to low-tech solutions in the building sector. All of these four terms, and I'm going to show it to you in my next example, have high relevance. I wouldn't say that this concept is preferable and the other one is inferior. No, we have actually translated this into 10 modules or building blocks of a holistic energy concept. This modular circle is made up of modules in 5 colors. I've developed it for both my lectures and for devising energy concepts at our office. The 5 colors represent 5 types of energy: heat, refrigeration, air, light, and electricity. So let's look at the right-hand side, the gray-shaded side. This is more about reducing demand, and this has to do with architectural options, intelligent design, etc. On the left-hand side, we have the active parts or components, and this is about producing heat, producing cold, using renewables if possible, very efficient systems. And if we go through these 10 modules, we will arrive at well-balanced holistic energy concepts. And these components well, I'm not going to break them down into details, but you will see later on when I introduce our projects that we always base our projects on these modules. Avoid overheating, natural ventilation, using daylight for the building and the human beings in the building, trying to minimize electricity consumption. And we are going to see projects that work with renewables, mainly geothermal heat, cogeneration, or efficient cold production for moderately cooling a building using a well. And this takes me to our engineering office. Lisa had mentioned it briefly. We have an office. It was founded in 1997 in Stuttgart, and our approach is to combine the active and passive sides. to develop holistic energy concepts with a focus on renewables. We have a total of 25 employees, and we are based in Cologne and Stuttgart. Stuttgart is our headquarters. This is where the office was founded, and we have projects all over Germany, and this means we have a really good reach. At the Ammersee in Bavaria, we are building a school of timber, and in Hamburg we have another major school project. So we often work for public clients. We build schools and administrative buildings, but we also have private clients. So we have a good mix. We develop energy concepts at the earliest possible point in time, including simulations, and we want, of course, our energy concepts to be substantiated by simulations. And in building physics, we can come up with the necessary equipment to plan all the 9 stages or phases of a building, and we have a building physics department, which is particularly important to optimize the building envelope, avoiding overheating, etc. These are the topics that are really important, as is preservation of heat. We carry out DGNB audits in line with the principles of the German Society for Sustainable Building, and this is a building that is quite remarkable. A lot of glass is quite obvious, and this is a landmark building for the Festo company in Esslingen. You may know them. They are an absolute innovation player. Festo is the go-to player and the market leader when it comes to automation and controls. All robotic systems have Festo components in them, and the clients wanted to be as innovative as possible with their new building in Esslingen. So we were given the mandate to do the entire design, including HVAC and all the other building services. And this is the center as it was planned by the architectural office Jacek. So they were responsible for the architectural part, and we were responsible for the building services. And it was taken into operation between 2012 and 2015. The building envelope is made of glass, and at the same time it is of very high quality. U values are at 0.16 for the floor and 0.19 at the floor. And we have glazing all around with a U value of less than 1. So it is an excellent building envelope, minimizing heat losses, but obviously we have transparency. And when it comes to transparency, the first question to ask is, how can we protect ourselves against overheating due to insulation? We see the blue windows with their blue rims. These are the windows with in-glazing solar protection, and you switch it on by applying a certain voltage. The G value is 0.34 to 0.1, and the rest of the glazing has a G value of 0.3. It is important to use natural ventilation in a high-rise building like this. You may ask yourselves, is it really needed to ventilate naturally in a high-rise building, because you have a ventilation system anyway? But it is important. It is important for people to be able to open the window, albeit slightly, even up on the 16th floor, is something that gives them additional quality of life. So people don't do it all that often, but it's important for them to be able to do it now and then and to feel the outdoor climate and temperature. And this is why the electrochromic solar protection was installed here. And when it comes to buildings with workstations, you can see that we have excellent glazing reaching up to the top of the ceiling, so it allows for a lot of daylight to come in.
So we maintain heat, we avoid overheating, we use the daylight, and we can lower the power demand, and such a high-rise building with elevators, well, that feeds energy back when you move down, for example, in electromobility in braking. Well, heat and cold production, very ambitious approach. Heat and cold generation, well, in such a building is best to be seen in combination, because although we'll talk about an innovative sun protection, we avoid overheating well, and for that purpose we also need cold energy. Where does it come from? Well, here we try to do with classical cold generation, and we combine it with heat generation. You can see it here is completely based on heat pumps. There's no fossil burning, no condensing burner, and no cogeneration heat and power plant. The heat pumps are operated electrically, and in case of heating, you have the possibility to use three sources of energy. Earth probes presented here in the icon, geothermal energy. A lot of energy is taken from the soil in large quantity. Then, of course, geothermal energy cannot do it alone at this location. It's something to do with groundwater protection locally. And therefore, we still use another element, an ice storage sitting below the building. And it's a simple solution because there are also ventilators to take in outside air. So systems can be combined very well, and depending on the situation of the outside temperature, the energy needed in the building, the low temperature heat source can be selected. Interesting enough, all these three sources at the same time can generate cold in summertime. That's to say, the systems turn upside down, and then you can produce cold also from geothermal energy and also from the outside air facilities. We can produce cold. Hence, quite a sophisticated energy scheme hidden behind it. And let's now see how the heat is transferred to the building. The building has partial activation in the ceilings. At the same time, of course, this is a very heavy system, which is very apt for this purpose. So the regulation of a precise temperature is not so easy. The ambient air temperature requirements in this building are 22 degrees centigrade, based on the wishes of the users, and hereby underfloor convectors. If there are few persons, you can bring in heat swiftly and hand it over to the room. And the concrete core activation only amounts to a minor base load supply. The partial activation has 3 axis covers from an energy point of view. And this is quite favorable because in these hollow bodies we do without concrete, and thus we minimize the mass and even the thermal mass on which the system relies. But it has been well investigated and simulated, with the result that below these hollow body ceiling, the core activation can be realized, especially for cooling. concrete core activation. So by moderate temperature in the houses, and surface temperature is produced at the ceiling, and with radiated cold, the building is cooled. Let's see it such that a highly glazed office building with its low-tech activation system concrete core need to do with. So this is the approach we need to realize, because at first glance, the building appears as a high-tech, but it's not a lot of air supply and air condition, but it's just this concrete core activation in order to generate pleasant temperatures. Apart from that, the user said it's okay if we can abide by the 26 degrees in summertime. Less excess temperature hours were tolerated. And there was a user, thanks God, who didn't say we want air condition at push button to adjust 22 degrees all the time, no matter what the outside temperatures are. And this succeeded even very well. Even in the most extreme summers, the temperatures were 26 degrees maximum. Even there, we had this underfloor system. Could also be used in summer if we have to cool down peaks. But the major portion of the cold energy is provided by these slopes, which are inserted in the ceiling. Now, the cold generation, I said before that there's an ice storage facility. This is accommodated below the building, 1,300 cubic meters large, and the concrete volume as big as a one-family house. And there's these plastics houses filled with water, like a swimming pool, with these tubes. Now, how does it function? What does it do with the building? Well, in case of wintertime, the heat pump operates, and if you know the function of a heat pump, you know that the heat pump needs a low temperature energy, the energy need to be pulled out somewhere. It does here on low temperature level. Then the heat is handed over to the building. Then heat is withdrawn time and again. And if you withdraw heat time and again, the phase change takes place sooner or later. The water freezes and becomes ice. And in this phase change, there is an enormously high energy density, which is provided. Hence, the change from water to ice corresponds to a temperature stroke of 80 Kelvin. Imagine how much energy is involved in this change. Hence, basically, we charge a battery in winter. From water is turned into ice. We store energy, and interesting enough, the battery, which looks like that, if it's frozen through in summertime, represents a natural source of cooling. Of course, everyone knows it. If you order a long drink and uses ice cubes, this stored cold energy can be retrieved long because of the melting off of water. Melting water becomes natural cooling water through a heat exchanger, and thus the building can be cooled. Hence, ice water serves the purpose of natural cooling to a major degree. Hence, what corresponds to winter-type heat generation is available as cold in summertime over a long period of time. But let's bear in mind that an ice storage facility alone does not suffice in summer, and therefore combination with geothermal energy makes sense a lot. How come? Earth probes are very good low-temperature source in terms of energy, and over a long period of time, they can withdraw heat from the earth in a moderate way. It's not that appropriate if extreme situations and if you need a lot of output over a short time, because then it can get ice covered. So in this case, it was not a water protection area, and it's a water protection area, and we may only transport water. Only water is allowed because of the protection of the groundwater, and therefore these earth probes need to be operated moderately over a long period of time. When it becomes cold, let's say below -10 degrees centigrade, then it's better to use an ice storage, because there we can withdraw energy over a short period of so here you see the construction situation. But basically, it's a simple PE probe which was used for this purpose. The ventilation concept, well, we considered hygienic minimum air changes. So there's no air conditioned through the air in the building, which would be the classical approach, but costs a lot of energy. But air is only transported such that it corresponds to the hygienic personal air exchange, and on top of that, it's also controlled by means of CO2. That's what it looks like. The concrete ceiling is equipped with these pipe hoses. The concrete core activation is there, and the visual concrete ceiling, which stays free, is accommodated in the floors, the sprinkler devices. So there's a very high density of such technical facilities. Well, in the office itself, we have a specific innovation, exhaust air facade. Intake air comes out from the floor centrally, also in the window areas at the facades. It is sucked off centrally at the elevator cores and at the sides of the facades in a switched fashion. This takes us to the exhaust air facade. Whenever the sun shines on one facade, a screen is activated, the screen moves down, shades very efficiently, but the screen is inside. Here you see it in the cut. The solar protection screen moves down, and with the facade, with the lateral areas, it seals off, and thus it forms an exhaust air duct. This is sucked off between the glass screen and the screen, and this means that the solar gains, despite the solar protection glazing, come in here and directly sucked off at the facade side, and they are transported off. So in contrast to conventional solar protection facilities, which are indirect, which don't have tight sealing in the interior, the air is sucked off precisely, in contrast to thermal supply, which leads to positive oiling.
Ja, diese Abluftfassade.
And positive turbulence. Well, in various tests, this was simulated and optimized. You see it here in the commissioning phase. You see the smoke generator, which shows what the flow is like behind the screen, between the window and the screen. Here, the sucking off in this position between the screen and the double floor. That's the air volume in hygienic form, which is taken in, but here it's used and sucked off to avoid overheating. Now, artificial light optimization in this special project, artificial light, presence control, daylight controlled. This is how it is adjusted. And this takes us to the last component, the central power supply inside. It's a photovoltaic station with 224 square meter module surface force, 31 kilowatt peak for a decentral power production. Second production, I've brought the second product with me, a second project, which goes into another direction. The German federal foundation environment in Osnabrück, with a holistic energy concept too. A shell, well, there we need to see that we work a lot with wood and hemp, hence a very ecological component, maintaining heat. There's a shell which is balanced from the window portion, many opaque shares, generating very good heat protection. And now we need to ask the following.
Let me ask Lisa. I can see 14 minutes are shown on the clock. How much time do I have left? Feel free to cover the remaining 14 minutes with your talk. Oh, that's fine. Thank you. So the fact that the envelope is so well balanced is absolutely key to this project. The architectural office that were awarded the contract had engaged us in the project in order to ensure that energy management was sustainable, and I'm sure that this was achieved by keeping the building envelope as simple as possible. Also in terms of shape, it doesn't have many protrusions or recesses. It is very dense, and this means that heat can be preserved in the building very well. If we look at the energy concept as it is, there are certain elements we should point out. There are skylights that allow the daylight to enter the building. There is overheating prevention thanks to a very well-balanced window share, and we have screens providing sun shading that can be adjusted. So the conceptualization helped us a lot on the passive side. And the building as such follows a low energy and low tech concept at the same time. So we'll get back to the special features of heat and cold generation in a minute. For this building, the idea was to create a plus energy building. And if you want to create a plus energy building, the envelope should be of passive house quality. So U values should be at 0.15 watts per square meter in Kelvin. And for the windows, we also have strict regulations, and this gives you good preconditions to achieve a plus energy building with decentralized power production. So thanks to the PV array, the building produces at least as much energy as it consumes over here. The building is low-tech because for energy creation or production, we use two systems that were already available. The German Environmental Federation has an existing building which is quite some years old, and it has a cogen plant in it, and we found that there were some performance reserves, so we actually connected the new building to this cogen plant in order to provide residual energy for heating. So we consciously did without a heating boiler, and we consciously did without any additional equipment. And we have a well system here. The existing well
Menge fördern kann und genehmigungsrechtlich
has a certain quantity of water to draw from this well, and building regulations actually would not have allowed us to extract a lot of water, but the quantity of water that we can extract is sufficient to provide moderate cooling to the building in the summer. As for the well, there is just an extraction well. You cannot feed water back in, so the extracted cooling water will have to be used for irrigation of the garden and the trees there, and the rest will just enter the soil superficially. I just discussed that heat and cold are provided by heating and cooling ceilings. There is a system that this system actually has the intention of providing heat and cold from above. You may wonder whether this is really doable, but it is doable if the building envelope is excellent, and since opaque and transparent components of the building envelope are very well balanced, you don't need all that much energy, so a heating and cooling ceiling is indeed suitable to supply heat in a controllable way. It can be done very well, and if you use the same heating and cooling ceiling in winter using the moderate groundwater well water supply, you can cool appropriately in summer and you can heat appropriately in winter. So this is a plus energy building based on the passive house concept, and the passive house concept, of course, calls for ventilation system. Here we have a highly efficient heat recovery based ventilation system. This is how the offices and the exhibition space are ventilated and heat recovery is provided. This should have given you a good overview of the building. Now let's look at the details. This is the timber structure with renewable resources being used for insulation in order to optimize the envelope, and the envelope has been designed and executed to passive house standards. You see a relatively small share of window surfaces, no more than 20%. At the same time, we have sun shading, we have static components, as well as a screen to avoid overheating. You can see that you can open and close these lids because we want every user to be capable of opening the window whenever they need fresh air. The ventilation system provides just the hygienically necessary quantity of supply air. And here we provide sun shading by applying a certain electricity voltage. If you apply the voltage, the the window gets tinted, the glass gets tinted, and this provides protection from solar irradiation. And here we can see the pipes installed. We installed them openly on purpose, and behind the heating and cooling ceilings we have a coil system, and the suspended ceiling also serves the purpose of improving indoor acoustic situations. So we have not hidden away the system in a closed ceiling, but we did apply some visual elements in between the viewer and the equipment. Here we have the two wells supplying the existing and the new building.
Die Ausstellungshalle, hier finden
And this is the exhibition hall. There are regular exhibitions held in this hall. The skylights cannot be seen here, but we have beautiful lighting for this room. And what I can show you here is the exposed installation of the ventilation system. The ventilation system was installed keeping the effort to a minimum. The ventilation plant is where the tubes or pipes come down from, and they are distributed across the whole directly. Maximum ventilation efficiency was what we had in mind here. When it comes to ventilation, it is important that you convey air in an efficient manner. We want the speed, the velocity of air in the ducts to be low in order to minimize electricity consumption. So it makes sense to transport or convey the air in a very efficient way, which at the same time enables heat recovery. So warm air from the building is used again to preheat the cold air that is supplied from the outside. And these are all important aspects when it comes to designing a plus energy building. Now let's move on to the next picture. This is the rooftop structure, the rooftop view, and we can see some of the modules which may send an important signal for pointing the way for future roofs. For one thing, you see the photovoltaic arrays, and this is where we are headed. We'll have to produce electricity in a decentralized way, and if you opt for a plus energy building, you have to provide electricity in a decentralized way anyhow. And we see how the roof greenery and the PV array are nicely combined in order to regulate humidity and temperature, and in order to regulate the draining of rainwater. And at the same time, the efficiency of the PV array is improved. If you have PV system which is placed in a slightly cooler location in summer, it is more effective, it can produce more electricity. And we see the skylights providing even entrance opportunities to daylight, regularly distributed across the entire surface, and we see that the protection from direct insolation is provided not by mechanical shadings, but by an electrochemical element that the glazing has been provided with. So this is a multifunctional solution, and I think this building really points the way of where we should go if we take a holistic approach, combining various elements in a very balanced manner. So we have seen two projects, and maybe I will leave it up to you to decide which of these buildings has been equipped with more high-tech or more low-tech solutions. Festo wants to show transparency. They want an architectural statement. They had a very clear idea in mind, and for us, it was quite demanding to turn this building into a holistic project. In spite of all the technical equipment we applied, we believe it's not a typical high-tech project. Many different ideas have been implemented here, and the environmental balance of the building was rated very well. It got a platinum certificate, and the building on the right-hand side shows how well the building can be tuned to a holistic energy concept. So even the architects who did the basic design were highly interested in the right orientation of the building, integration in the site, and other aspects that provide a good basis for sustainable design. Thank you very much for your kind attention, and if you have any questions, I'll be more than willing to answer them. Thank you so much, Markus, for this interesting presentation. We have a couple of questions. Wolfgang Blume asks about whether hydrogen is the real-life future or whether it is just a vision for single-family homes, and whether the municipal facilities shouldn't be used for hydrogen. That's a good question. First, I think what has been said last is a good option. The gas grids that are available in the municipalities are good and they can be used for hydrogen transport. But the second question is, how do we handle the storage issue? Will we have lithium-ion batteries for energy storage? Batteries that need less gray energy than they need today, or will we get specific hydrogen storage facilities to enable us to oversupply our buildings with solar energy in summer and store the excess energy in a hydrogen tank? Fraunhofer did this a couple of years ago in Freiburg, and thinking 10 or 20 years ahead, I would not exclude that there are small-scale hydrogen tanks for single-family homes. And Markus Pence asks about whether what the percentage repartition of high and low-tech projects is in your office. Good question, Peter. Well, we do not really have a clear-cut repartition or distinction between high-tech and low-tech. The two projects I presented today are maybe extremes. The DBU project is a beautiful low-tech project, and the Festo concept shows high-tech elements, of course, with its very special facade. Most projects are somewhere in the middle of these extremes. You don't have those extremes all that often. But currently, I feel a strong move towards highly ecological projects. Timber construction is on the rise, and that's something that I really like. So there is a strong demand for sufficiency-compliant buildings. Okay, and next we have a comment from Renate Ture. We can assume that offices will be less densely used due to working from home, and aerosol burdens will have to be considered accordingly. Will that have an effect on your projects? We always try to ensure that air is hygienic, but we would not probably supply an extra quantity of air in order to avoid aerosols. The question is, where are the air inlets and where are the air outlets? That's a key question. And secondly, you have to convey air in such a way as to meet the demand in place. So we have carbon sensors measuring whether there are people present at all and whether the air needs to be renewed, and we provide the quantity of air needed for regular replacement. Dirk Bornhorst asks about what percentage of the cooling is provided by the active cooling ceiling compared to, say, nighttime ventilation. And this refers to the second project, the low-tech project.
Low-tech, there's no night cooling concept. We simulated it. The building is a light design because of the wood. So it doesn't make sense to open windows and flush through overnight. As you have seen, these window surface areas are so small in the building that there is no issue with overheating. And in summer, when it really becomes very hot, with a few cubic meters cold water, with the well water removes through the ceiling, that works fine, no further effort needed. In many other concepts, well, as we can see, there's an issue of housebreaking protection, impact protection, insect protection. Then you may want to have automatic window opening, which is a bigger effort, of course. Well, next question from Sarah, thanking for the great presentation. Then she wants to know how the owner of the high-rise building could be convinced easily and whether he was around from the beginning. Well, there was no one around the table who called himself an innovator, but so if you have this challenge as an engineer and if you can think into all directions, if you can use everything which is available on the market, that is really great. So that was the case in Festo super project. Maybe a small anecdote for it. You know, there were geothermal probes, these plastics, tubular houses, and we always used these double PE duplex probes. That's the product on the market, but Festo wanted to know whether there is something even better, and we did the most various series with coaxial and high-grade steel probes, which we measured with a big effort in order to take a little bit more energy out of the soil. And then, as a result, we used the simple probes, but it shows the ideas of the owner. He wanted to know everything precisely, and he was the right one to realize that these exhaust air facades. They developed them for the first time with architects and facade planners. They had built it up at the Fraunhofer, and they did mock-ups in a big effort, and that was really great in cooperation with that owner. Well, I hope we get more of them. Having said this, let me thank you very much for your presentation and you for your participation, for your questions. And of course, you can get in touch as usual. And I would like to thank Mr. Frankfurt for the cooperation with all the technical facilities and technical support. Thank you very much. And now, I say goodbye to you and enjoy the rest of the day of the ISH.